What's up, guys? Myas is here, and we're at 5-4B for Essentials of Calculus. We're going to look at acceleration, velocity, and position, although they don't go in that order. But we talked about them before when we were talking derivatives. Now we're looking at antiderivatives. So let's take a look here. There we go. So if we know the acceleration of an object and we're given initial conditions for the object's velocity and position, then we can actually do integration to go backwards and go velocity or position. So the thing you really need to remember with all of these is the order in which these go, okay? Position, the derivative of position is velocity. The derivative of velocity is acceleration. If we're going backwards, then the antiderivative of acceleration is velocity. The antiderivative of velocity is position. Okay, so just know where we're starting and then where we're going, so you know whether you need to do the derivative or you need to do the antiderivative, basically. And it's a good idea to kind of, if you get to a position velocity acceleration problem, to just maybe draw this out really quickly, either in your head or on your paper really fast, so you can see, know what you're doing there, okay? So let's take a look at an example. The acceleration of a particle at time t is given by a sub t. And we know the velocity and we know the position for that particle. So we're going to find the velocity equation. So the first thing we're going to do is we are going to do the antiderivative of the acceleration. All right, so that's going to give us, we're going to do the power rule, so 4t squared divided by 2 minus 3t, and then we're going to have plus c. Now, this is going to be v sub t. But we need to solve for c. So we're going to plug in. We're going to plug in what we know. We know v sub 1, so we're going to plug in 1 for t. Just so you know, 4 divided by 2 is 2, so I just changed that. 3 times 1 plus c, and we know that that's going to be equal to 6, because that's what we're given. All right, so we're going to use this to solve for c. 2 minus 3 plus c equals 6. Negative 1 plus c equals 6. C equals 7. And then we're going to go and put it back here, and we're going to put our answer as 2t squared minus 3t plus 7. All right, so that's our velocity equation. Sounds good? All right. Okay, so now we're going to go ahead and find the position equation. And we could find the position equation by using our velocity equation. So remember here, the integral of velocity is position. So we're going to do it one more time. So the position is going to be the integral of 2t squared minus 3t plus 7. I'm going to zoom in here so I can write a little better here. All right, dt. And I'm going to have 2t cubed minus 3 minus 3t squared over 2. Remember, I add 1 and then divide by that number. 7t plus, and I'm going to call this c2 because I already used c on the top, so I need to use something else down here. I can't use c again, so I'm going to use c2. And I'm going to go and plug in. What did I know? It was s sub 2. Okay, so s sub 2. So I'm plugging 2 into my formula. 7 times 2. And I know that that's equal to 5, I believe. Yep, 5. All right, so I'm going to use that to solve for C2. So we got a little bit of math here to do. So we're going to have 8. 8 times 2 is 16 thirds. Minus 2 is 4. 4 cancels with that, gives me a 3. That's going to give me 4. 2 is going to be 6. Plus 14. Plus C2 equals 5. Okay. So what's the easiest way to do this? So, okay, we're just going to go ahead and add the 6 over. Well, let's just put these two together, and we're going to get 16 thirds 16 thirds plus 8 plus c2 equals 5. We're going to go ahead and subtract 8, subtract 16/3 from both sides. We get c2 equals negative 3 minus 16/3. Negative 3 is 9/3, right? 9/3. So c2 is going to be negative 25/3. All right, so then we're going to put that over here, and we're going to find our equation. So our equation is going to be 2/3 t cubed minus 3/2 t squared plus 7t minus 25/3. All right. So the point of this video, guys, is just so you know here, when we're doing position, velocity, and acceleration, just make sure you know which ones go where. All right. How you go, either if you're going this way, you're going to do antiderivatives. If you're going position, velocity to acceleration, you're doing derivatives. And if you're going to do an antiderivative, then you given some initial positions here or an initial velocity, or it might not need to be initial, but we're given some information about the velocity and acceleration at a certain time. We can go ahead and solve for our constant so that we can find our formulas for velocity and position. All right. Okay, guys, we'll talk to you soon. Bye.